Modular production is a powerful strategy for achieving flexibility and scalability, which are crucial for staying competitive in today's fast-paced and ever-changing market. In this video, we will demonstrate some basic production principles and how efficient production are challenged by increasing product complexity. Let's have a look at the simplest production line setup, only handling one variant. In such situation, it is possible to design a well-balanced and streamlined production flow, where every step of the process is synchronized, preventing interruptions, delays, and backlogs. By eliminating bottlenecks and optimizing task sequencing, production can proceed without disruptions. However, as product complexity increases with more variants, such as different sizes, features, or configurations, more complexity may also arise in the production process. Different product variants may require specific adjustments in assembly or testing, affecting the consistency of flow. In the end, the added complexity can cause fluctuations in the takt time, leading to delays in certain stages. As the system struggles to accommodate the varying needs of each variant, it may result in a backlog, ultimately delaying the overall production. A frequently overlooked aspect is that the complexity added to the product range often carries over into the production process. When new design variants are introduced to the product architecture, the same variability must be managed throughout the production flow. This increased complexity can present significant challenges, such as difficulties in balancing the line, a higher likelihood of errors, reduced repeatability, and challenges in automation and worker training. Ultimately, these issues can negatively impact overall output and efficiency. To overcome the challenges by increased product complexity and variability, several well-known principles can be applied to optimize the production process. Within the approach of line balancing, the disruptions can be accommodated by adjusting the workflow, by adding more workers to specific steps, or redistributing tasks between steps, or even introducing new steps to accommodate the added complexity. Another method is to implement a late decoupling point, where common part of the products are processed at the beginning of the production line, and the unique or customizations are handled towards the end. This approach helps minimize variability early on, reducing its impact on the flow. Lastly, separating low-volume product or the specialized ones from high-runner products can streamline production, allowing high runners to maintain efficient flow while managing less frequent variants separately. These different strategies help optimize production by better managing variability, ensuring smoother operations and improved overall output. Another effective way to ensure an efficient production setup that can handle the product complexity is through a modular production setup. The principle behind this approach is to design a stable core process for the main production flow, where the same steps and processes are applied to all products. The variability in terms of design variants is handled within separate sub-assemblies feeding into the main line. Each sub-assembly or module assembly is tailored to accommodate specific variants, allowing for different process setups within each module. By isolating variability in sub-assemblies, the main production line remains streamlined and efficient, while still accommodating a range of product variants based on the incoming modules form the sub-assemblies. Based on over 600 projects, we have developed a methodology and framework specifically designed to operationalize the process of defining a modular product architecture and translating it into a modular production setup. This methodology provides a structured approach that spans from defining the product structure in modules to optimizing how the product is produced. Having an end-to-end setup based on modular principles provides a comprehensive overview of the entire product range and production process. This interconnected framework enables your organization to easily assess the impact of introducing new variants or making changes to existing products. With clear visibility across the product architecture and production flow, decision makers can quickly identify potential bottlenecks, resource needs, or necessary process adjustments, ensuring modifications are efficiently managed and their effects understood across the entire system. If you want to know more, feel free to contact us.